lets any computer run an interactive 3D interface. My first experience with a hologram was, like so many other people's, completely fictional. A small, blue figure projected from R2-D2 in the original Star Wars. About a decade later, I got a taste of the real-world state-of-the-art from New York City's Museum of Holography, now closed. Holograms did exist in all their 3D glory, but they were static. You committed to displaying one image when the hologram was made, and that was it. No animated messages from princesses. But there has been progress since. Holographic displays with actual refresh rates, albeit painfully slow ones, and other approaches have been described, but products based on any of this have yet to appear. Meanwhile, non-holographic approaches to 3D have taken off. TV and movie screens feature 3D viewing with simple glasses, but don't allow interactions. Immersive goggles and gear do allow interaction, but only for the people wearing the goggles, which isolates them from anyone nearby. So we were intrigued when we got an offer to visit Looking Glass, a Brooklyn-based company that's offering what they're calling HoloPlayer One, a 3D projection system that lets users interact with the projected images, all without goggles or glasses. And, perhaps most importantly, it was almost ready for market. Non-holographic systems create the illusion of visual depth by taking advantage of how our visual system normally works. Our eyes aren't capable of much in the way of depth perception individually. Instead, slight differences in the information obtained by our two eyes are interpreted by the brain to provide information on depth and relative locations. This happens naturally because our eyes are slightly separated. That separation is enough so that they view three-dimensional objects from slightly different distances and perspectives. To appreciate just how much this matters, all you need to do is spend a chunk of your day trying to navigate life with one of your eyes closed. But it's possible to trick the brain into thinking an image projected from a flat screen has depth. The oldest, dating back to the 16th century, is Pepper's Ghost, which relies on a combination of mirrors and some partly reflective glass, as well as distance. You need to be far enough away from it so that other visual cues about depth don't spoil the illusion. This was most famously used to create a live performance from deceased rapper Tupac. But the alternative is to simply feed your two eyes slightly different images. The 3D glasses you get at the movies simply place different filters in front of each of your eyes. Combined with the right content, this ensures that your eye sees slightly different images. VR goggles simplify matters even further by placing different screens in front of each eye. Sean Frayne, founder of Looking Glass, indicated that the HoloPlayer operates under similar principles. It ensures that, as long as your face is positioned within a set distance, a meter or two, and viewing angle, your two eyes will see different images, allowing your brain to interpret the display as three-dimensional. But it doesn't need any goggles or glasses in order to do so. How does that work? The foundation of the system is a standard LED display. But the hardware is split up into 32 overlapping sub-displays, each showing a slightly different perspective on the item that's on screen. These sub-displays are interlaced, meaning their pixels are mixed in together, rather than being individual, discrete images arranged on a grid. Looking directly at the LED display, this produces a fuzzy-looking version of the object. The magic happens after the light leaves the LED display. First, it reaches a partially reflective, polarization-sensitive mirror called a beam splitter. This will reflect light only when it has a specific polarization and is arranged to match the polarization of the LED. It sends light back into the hardware and toward a space above the LED display that's covered by a reflective coating that also rotates the polarization of the light. When the light comes back out of the device and reaches the beam splitter, the polarization has changed so that it's no longer reflected, allowing the images out of the HoloPlayer. As a result of all of these reflections, the individual displays end up slightly separated in space. The separation is enough to ensure that your eyes will see different images, which your brain then interprets as a three-dimensional view. The system is flexible enough to improve with technology. Frayne showed us a version with a higher resolution display that looked notably better. It's also possible to have the 3D view appear inside the hardware, which also seemed to improve the image quality. But that takes away from the system's other selling point, depth-sensitive interactivity. Just above the light-manipulating hardware, the holoplayer is equipped with an Intel RealSense camera that is capable of tracking fingers,